honestly. I just like the satisfying pop. It's like a nice sound. All right. So this is related to a topic called Bezier curves. It's really cool. It's cool stuff. I like it. It's got historical context too, because basically the curves that make up like the design of cars and things like that, they have their roots in Bezier curves. So, like if you ever wondered how they came up with the function models to represent, like, you know, you have the hood of your car, then it goes into the main cab, the roof of the cab, and then into the trunk. That function curve when they're designing it is rooted in Bezier curves. So it's pretty cool when you think about it that way. And also, like, I mean, this is old school, but original typesetting, like for typewriters, and then eventually keyboards and things like that. I really need to stand over here because I'm gonna like not sound good. They were all rooted in Bezier curves also, because what they needed was some kind of function to represent these things, like the letter S or the letter B. You know, some kind of function that they could use over and over and over again when they're writing the code for like word processing software and things like that. All right, so Bezier curves is actually how this came into being. And that's related to specifically parametric functions. So it's kind of cool, but as you can see, based on the nature of the assignment, they're kind of involved. So this whole shebang in here has to get typed in. All right, so that's fun. So how do you do that? Well, you start typing. All right, it's as simple as that. So my first move is going to define it as A equals. It helps if you write the A equals. Most of the time it'll automatically define it as A, but sometimes it doesn't. Sometimes it kind of goes rogue. You got to be very careful because it's very temperamental. So I'm going to type in 4. Now, you would think that I could just type in 4 parentheses 1 minus t to the third power. If you're including a product in GeoGebra, in this context, if you don't put the multiplication symbol in there, it's going to give you a hard time. All right, so I'm going to type in multiply. Now, when I hit enter, that multiplication symbol is going to disappear for some reason. I have no idea why. It's just aggravating. 1 minus t, close the parentheses. Now, the power of 3, you could actually use a caret, you know, shift 6, but a nice nifty shortcut is to hit alt and then 3. All right, so alt and then 3 will bring up, well, alt and any number will raise that to a power, right? So that's kind of nice. So then plus 84 times t, that's not a t, times t times, oh, I'm hitting like random buttons here, times 1 minus t squared. So 1 minus t squared, alt 2 gets that job done. Close up the parentheses. It closes them up automatically, but I like to do it just to be safe. Safe from what? I have no idea. Safe from mysterious GeoGebra failings. So 150 times t alt 2, all right, then times, and the reason I like alt better than the caret is not only does it make it into an exponent, but it also brings the cursor back to regular size. So you don't have to worry about hitting the right arrow to get you out of being an exponent. Because I've had that happen before where a student will get it into exponent and then type the rest of their function as an exponent and then wonder why things went wrong. So, you know, it's like little things. 1 minus t, close them up, plus 40 times t cubed. All right. Now, comma, all that stuff again, but with different coefficients. All right. So now this is the dangerous thing, because this is what I'm going to try to do. Control C that bad boy. But you got to be careful if you accidentally hit enter or click out of the field or something like that, it could wipe out everything. and then you'll cry. All right? And you know what? Honestly, I don't think I'm kidding about that. I think there are enough of us that would be moved to tears after typing all this stuff and have it all get wiped away, that I think that that's a true statement on my end, that yes, there is at least a few people in here that would cry. I think I would cry after letting loose a string of profanity. So I changed my coefficients. All right. Now, comma, whenever you put a parametric in GeoGebra, you always got to put your variables, or so like what x is equal to, what y is equal to. So the two different functions. Then you have to define your variable. So t, I got to tell GeoGebra what the variable is, and then the domain. All right, the domain for t. For this, it's sufficient to just go from 0 to 1. After you get all the individual characteristics in, it should produce what it thinks is the proper line below. When you hit enter, it locks it in, and then you can breathe a sigh of relief. All right? And so as long as that looks like what I have here, now you might look at this and say, well, it doesn't look anything like the picture. Well, look at the scale. I'm going to 40, so zoom out. It's there. It looked like a line at first, but when you bring it out, it looks a lot less like a line. All right? And then you can play around with the zooming. You know, it really doesn't matter as long as it's this general curve. All right? A Bezier curve has control points. Those control points work their way into the function. So, like, for example, a is equal to 4, 1. Got to be careful where you type it. A is equal to 4, 1. You don't want to overwrite anything. B is equal to, now these are default values, so if I don't type A equals, B equals, it's going to be all right in most cases, but every now and then it'll be a little out of whack. What is that, 2848? All right, C is equal to 5042. All right, and then D is equal to 45. All right, so now I'm just going to go through and look for my mistake. Let's go back to my function here. Here it is. I did 1 minus t squared when it should have been 1 minus t squared. Classic Bob. And there it is. All right, so I had a Bezier curve, it just wasn't the right one. All right, anytime you make an edit, it brings it to the bottom of the list. So the fact that this happens after that, that doesn't matter to anyone, so it's fine. Now I want to include segments. So I want segment AB. What's that? Not that I know of. Did you already do it?
I think so, yeah.
Oh, good. One less thing to worry about. Yeah, I posted all the tech assignments up, so I was just going to go over them one at a time, but there's no reason, and this goes for everyone, there's no reason why you have to wait for me. If you think you can handle them, then just go right to it. Segment, segment, no, segment. There it is. All right, accidentally have another one there. I don't need that. Actually, it plotted it even though this is a completely ridiculous statement. Well, that just looks stupid, so let me get rid of it. Segment, C, D. There it is. Okay, so that's a significant chunk of it out of the way. So then what I want to do is create tangents. So tangent. Now, you can very easily get to a point where you're just kind of going through the motions and you're like, oh, I'm just following steps without considering what you're doing. What this is asking us to do is create a tangent through point A, all right, to the curve itself, all right. So A is somewhere. Yeah, it's there. It's just kind of hidden. I just wanted to see where it was written. Oh yeah, A is the curve. It's defined as the curve. Now, if you had that curve defined as something other than A, remember in my first step I wrote A equals. If I didn't write that and it called it like Q1 equals, then this is not going to make sense, right? Because it won't know what A is equal to. But here we're good. It's creating a tangent through point A to the curve A, which is the parametric curve. All right. Then I also want tangent through point D to the curve A. All right. So this is what the Bezier curve should look like. Now, one of the characteristics of the defined Bezier curve is that it has to have this relationship where the tangent through the point A and the tangent through the point D, these are the two control points, have to go through the control points B and C. All right? Otherwise, it's not a Bezier curve. All right? So if that didn't happen, if these tangent lines didn't go through both B and C, then there would have been something wrong. It wouldn't be a Bezier curve. All right? Now, the fun part, so you would save this. I'll save mine. It's like my 40th time doing it, but I'm still going to save it. Fall 2019. I'm going to put it on private so nobody goes into mine and copies and pastes it and creates it as a new file. Learned that one the hard way. All right. So now I have it saved, right? Saved successfully according to that. What I want to do is make use of the work that I've already done, because I don't want to have to do all this stuff again just to create sliders. All right. So now I'm going to create numeric sliders instead of the control points being defined specifically as 4, 1, 28, 48, and so on. I'm going to let them vary. All right. So I'm going to create sliders that's going to allow that to happen. So I can do this one of a couple of ways. One way would be to just clear out all this stuff. So delete, 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 and just work off of this. All right. So now you'll see that one of my sliders is A. So that's going to be a problem because I need A for something else. So what I'm going to do is I'm going to call this, I'm going to call it something else. I just want it out of the way. I'll call it Q. All right. So I have my Bezier curve. That's a particular Bezier curve. So what I'm going to do now is I'm going to create sliders A. And let me bring this up a little bit. Oh, maybe I'll just kill this. So A equals, and it'll automatically create a slider. All right, B. If I just hit B, you don't even need the equals. C, D, E, F, G, and H. All right, A, B, C, D, first 4 coefficients. All right, E, F, G, H, that's the second set of 4 coefficients. All right. So now what I want to do is redefine my curve so that it's in terms of that information. All right, so I'm going to hit duplicate on this. It's going to bring it down here. And now instead of having 4, I'm going to make it A times. Instead of 84 times T, I'm going to make it B times T times all that stuff. And then 150, no thank you, C times. Instead of 40, D times. Then E times, and so on. And then finally H times. All right, when I hit enter, it locks it in, but it allows me, you know, I'll just slide h around. H is the last coefficient here, the coefficient of t cubed. Slide it around, you can see it's manipulating it, but it's also, see that little bit of schmutz down there? That's the Bezier curve that's in particular to this situation. So what I can do is I can turn off this other one and start playing around with these coefficients and see what I get. Now it's so tiny that it's like, well, this is awful. But I can bring it in significantly. Now I just need to play around with this until I get a reasonable approximation of the letter C. All right, so just keep moving it. Oh, that's getting there. You get the idea, hopefully. Give it a little belly. I don't like that. Reasonable enough, but I mean, some of us are more perfectionists than others. So you play around with it, and then there you have it. All right. So then, save as a new file. Letter C, for example. And so now you have your work. All right. So yeah. So all I need you to do is come up with the letter C, because I don't know why. I mean, really, I mean, you can come up with any letter you want as long as it's a letter. But C is the one, you know, that's the one you want to go for. Because I mean, I just showed you how to do it, right? But the directions for number 6 are not the best. I need to rephrase that. But basically, it's saying, you know, come up with a letter of the alphabet. The letter C is preferred. But these links are getting popped right into that same Google Doc that you used for the first tech assignment, just in the area where it says tech assignment B. So you're going to have a link for the first part and a link for the second part. Unless you have it all on the same one, that's fine. Then it would only be the one link, but I find it a little easier and more organized if you have it as 2 separate links. All right, but I'll let you be the judge of that. That's not what I wanted to do. So